Good evening, dear students. So yes, today we are going to start with the next chapter. Okay, so the next chapter which we are going to discuss is structure of atom. Okay, structure of atom. So what are the important points which we have to remember from this particular chapter, that is structure of atom? Okay, so what do you mean by structure of atom? Okay, so basically what is present in atom? Okay, what are the fundamental particles? Okay, so atoms, we know atoms. Okay, so they are composed of what? They are fundament. What are the fundamental particles which are present in atoms? The fundamental particles like electron, protons, neutrons, right? So in this chapter, we are basically going to discuss, okay, you might have discussed about the different fundamental particles. So what are the important things you have to remember from this particular chapter? Okay, so firstly, you have to remember the properties. Okay, you have to remember the properties of electron, proton, and neutron. So what all are the different properties? You should remember the mass. Okay, so remember the mass of the electron is 9.101 into 10 raised to minus 31 kg. Please note it down. Okay, some of the important points. Then what is the mass of the proton? 1.67. Okay, 1.67 okay, into 10 raised to minus 27 kg. Then mass of the neutron. What is the mass of the neutron? Mass of the neutron, it is 1.674 into 10 raised to minus 27, okay, kg. So this is the mass of the neutron. Then second is the charge. Second is what? Charge. So we need to remember the charge of the electron, proton, and neutron. So what is the charge, students? Charge of the electron is 1.60. Okay, it is 1.60 into 10 raised to minus 19 coulombs. Okay, C is nothing but it is coulomb. It is a charge, okay, which we are representing in terms of coulomb. Then proton, the charge of proton is 1.60 into 10 raised to minus 19 coulomb. Okay, proton. And what is the charge of neutron? It is 0. Okay, neutron is a neutral particle. Then what we need to remember? So mass and charge. Then we have to remember the charge with respect to proton. Okay, we know electron is what? Electron is negatively charged particle. Okay, we need to know that electron is a negatively charged particle. Okay, then proton is what? It is a positively charged particle. So we represent as +1, and electron is represented as -1. Okay, and neutron, it is a neutral particle which is given as 0. The charge is 0. Okay, so this is a relative charge. So please remember these things. Okay, then next point which you have to remember is the discovery. Who discovered? Okay, so electron, it is represented by E, and it was discovered by whom? It was discovered by Sir Thomson. Okay, it was discovered by Sir Thomson. Okay, then proton. Proton, it is represented by P. Okay, proton is represented by P, and it was discovered by whom? It was discovered by Goldstein. Okay, proton, it was discovered by Sir Goldstein. Then he was a scientist. Next is neutron. It is represented by N, and it was discovered by Sir Chadwick. Okay, it was discovered by scientist Chadwick. Okay, please remember these four things: mass, charge, relative charge, and discovery. I hope you have noted down. Okay, so next, what are the points which we have to remember from this chapter? Okay, so how we are going to consider the nature of electromagnetic radiation. So you have studied something called as EMR. Okay, EMR is nothing but electromagnetic radiation. Okay, so electromagnetic radiation, it is given in terms of two theory. Okay, wave theory. Okay, first we are going to discuss in terms of wave theory. So that is the light. Okay, the light is considered to be in the form of light. Okay, it travels in the form of wave. Okay, it travels in the form of wave. So we consider that light, it is what? It is a form of wave. Okay, and it is represented by wavelength lambda. It is represented by wavelength lambda, and the frequency is given as mu. Okay, the frequency is given as mu, and the velocity of the light is given as c. Okay, so remember this formula, that is mu is equals to c by lambda. That is your that is frequency. Okay, frequency, how it is related to velocity of light and wavelength. Okay, that is c by lambda. So please remember this formula also. That is light. Okay, we consider light in the form of a wave. Okay, and how the wave is represented? A wave is represented by wavelength. Okay, and that is lambda, that is mu, which is a frequency, and c is the velocity of light. So it is given as mu is equals to c by lambda. Also wave number, so you might have so please remember the definitions. Okay, definitions are you might have already discussed in the class theory part, so I'm not going to tell the definitions. Please go through the definitions of what is wavelength, what is frequency, what is velocity of light, what is wave number. Okay, wave number, how it is represented? Mu bar. Okay, mu bar, and wave number is calculated as 1 by lambda. Okay, so based on these formulas, we are going to solve the problem. So remember these two formulas again. Okay, so remember these two formulas. Fine. So the light waves, okay, as we know, light, it is traveling in the form of a wave. Okay, it is considered as electromagnetic in nature. Electromagnetic in nature means what? It consists of both. It consists of a electric and magnetic field. Okay, so when light is traveling, okay, when the light is traveling, it is traveling with what? It is traveling in the form of a wave, and what is present? There is a presence of the electric field as well as the magnetic field. Okay, electric as well as magnetic field are present. So light is represented, or it is called as a electromagnetic in nature. Why it is called as electromagnetic in nature? Electromagnetic, electric. Okay, electro means there is a presence of an electric field and a magnetic field. Okay, and this was given by, or it was told by, scientist James Maxwell. Okay, in the year 1873. So there are different electromagnetic radiations, and these different electromagnetic radiations, they are arranged either in increasing wavelength or decreasing frequency. Why we are saying increasing wavelength and decreasing frequency, students, here? Because wavelength is inversely proportional to this frequency. Okay, so either if you increase the frequency, wavelength will decrease. Okay, or if you increase the wavelength, frequency will decrease. So it is vice versa. Okay, what happens here? It is vice versa. So electromagnetic radiation, there are different electromagnetic radiation, and how this electromagnetic radiations are arranged? They are arranged in increasing wavelength or decreasing frequency, and it is given in the form of a spectrum, which is called as a electromagnetic spectrum. What it is called as? Electromagnetic spectrum. So remember, now next important thing which you have to remember is this particular box. Okay, here you can see. Okay, this is the, here you can see. So energy. Okay, here you can see. So these are the different frequency. So this is in terms of a wavelength. Okay, this is in terms of a wavelength, and this is in terms of a frequency. Okay, so this is increasing wavelength, and so like this, the frequency is increasing. Sorry, like this, the wavelength is increasing. Okay, so from left to right, there is increase in wavelength, and from right to left, there is a increase in frequency like this. Okay, so what do you mean by shorter wavelength? Shorter wavelength means the distance between the two troughs. Okay, or two, this is a trough. Okay, so this is a trough and a, so like this. Okay, so the distance between these two troughs, it is called, so you can see the distance is very small, so it is said to be a shorter wavelength. And when the distance is more, okay, between the two troughs, then it is called as a longer wavelength. Okay, so here when we are seeing the electromagnetic spectrum in terms of increasing frequency or decreasing wavelength. Okay, what first comes is your gamma rays. So gamma rays, what is the wavelength? 10 raised to minus 12. Okay, in 10 raised to minus 12, what you can see, the gamma rays falls. Okay, and then comes your X-ray. X-ray is 10 raised to minus 10. Then comes your ultraviolet rays. Okay, that is your UV rays. UV rays. That is 10 raised to minus 8. Okay, then this region, okay, you can see the black part. This is a visible region. Visible region means what? Visible region means your VIBGYOR. Okay, that is from, so remember that what is the wavelength. Okay, what is the wavelength of visible region? So remember this also very important. Visible region wavelength is 380 nanometer, okay, to 780 nanometer. Okay, what is the reason? Is it visible now?
Yes, ma'am.
Okay, fine. Okay, so this is our frequency. Okay, so this is the frequency. So here is the, okay, so here what you can see here. So what you can see, so either, so this is a electromagnetic spectrum. So electromagnetic spectrum, it is how it is arranged, either in increasing frequency or decreasing wavelength. Okay, so it starts with our X-ray. So it starts with our X-ray, which falls in the wavelength of 10 raised to minus 12. Then is our gamma rays. First is our gamma rays. Then 10 raised to minus 10 is our X-ray. Okay, then is our UV rays, that is 10 raised to minus 8. Okay, next is the region. Okay, the region that is between 380 nanometer to 780 nanometer. It is called as a visible region. So please make a note. So 380 nanometer to 780 nanometer is our visible region. Okay, what do you mean by visible region? That is the colors. Okay, VIBGYOR, VIBGYOR. Okay, so the colors like violet, indigo, blue, green, yellow, orange, and red, it falls under this particular region. Okay, so this visible is this region, it is visible to our naked eyes. Okay, we can see these colors, right? So it is called as, this is a electromagnetic spectrum. Next is 10 raised to minus 6. So in the wavelength of 10 raised to minus 6 is what? It is our infrared region. Okay, what is that? Infrared region. That is our IR region. Okay, it is infrared region. Then 10 raised to minus 4 nanometer is microwaves. Okay, microwaves means what? They are used in the micro oven. Okay, so this particular waves, they are used in micro oven, or they are used for small transfer of sound. Okay, microwaves, then radio waves, they are used in FM. Okay, AM, FM, so their radio waves are used. So these are the different regions of your electromagnetic spectrum. Okay, so this is in increasing wavelength. Okay, so this is in increasing wavelength, and from right to left is your, and here this is a decreasing frequency. So increasing wavelength and decreasing frequency. So this is the what? Electromagnetic spectrum. This is what? Electromagnetic spectrum. Okay, fine. Next. So based on this, so what, just a second. Okay. So first let us complete the synopsis. Okay. Okay. So next is quantum theory. Next is what? Quantum theory. And there was a scientist called Planck. Okay. Planck was a scientist. And what he gave the quantum theory. And according to quantum theory, energy is associated with, okay, H into nu. Okay. So the energy is radiated or absorbed by a body, not continuously but discontinuously, in the form of small packets, and these small packets, they are called as quantum. Okay, so the energy, whatever the energy is radiated or it is absorbed by a body, it is not, the energy is not passed continuously. The energy is not passed continuously, but it is passed in a small forms, okay, or small packets. That is called as quantum. Okay, and the quantum is nothing but the photon. Photon is nothing but your light. Okay, so energy is represented by H into nu. We know what is nu. Nu is equals to C by lambda. So if we put this value in place of nu, we will get what? E is equals to H C by lambda. So this is our Planck's, this is our what? Planck's quantum theory. Okay. So remember this one formula. Okay. Please remember this one formula, that is E is equals to Hc by lambda. Okay. So this was energy. Okay. So this is in terms of energy. So energy is associated with the small packets, and that is quantum. Okay. Or it is called as photon. And this was given by the scientist Planck. Okay, so his theory, this is Planck's constant theory, which is given by E is equals to Hc by lambda. So this particular formula, please make it a note. So by using this particular formula also, we are going to solve the problems. Okay, fine. So after this, okay, quantum numbers and all, we will see later. Fine. So uh, based on this, let us solve some problems now. Okay. So first question is based on quantum numbers. So before that, we will discuss about quantum numbers then. Yes. So do you know about what are quantum numbers? Yes. What do you mean by quantum numbers? So whenever we are discussing about electron, okay. So each electron, it is represented by four set of atoms, okay. So each electron, it is represented by what? It is represented by, what? It is represented by a set of four quantum numbers, okay. And what are the four quantum numbers? Very important. This quantum number for theory point of view, okay. So this is a question for 3 to 4 marks. Okay, 3 to 4 marks. What are quantum numbers and give the significance of quantum numbers. So please note this question. Okay, this is a question asked in theory also. What are quantum numbers and give the significance of four quantum numbers. What do you mean by significance? Significance means importance. Okay, you have to tell the importance of the four quantum numbers. What are the quantum numbers? Quantum numbers means what? We know that electron is present. Now hydrogen. Okay, if we consider hydrogen, how many electron is present? One electron is present. Now this one electron, okay, it consists of four quantum numbers. Okay, it consists of set of four quantum numbers. Suppose next is our helium. How many electrons it has? Two electrons are there. So each electron, it is having a four set of quantum numbers. Okay, so each electron, okay, it is in an atom, it is identified by four set of quantum number. Suppose one student is there, okay. Now how he is represented? If a student is there, how he is represented? He is represented first by his name, okay, then by his, suppose another person is also having the same name. Suppose okay, the both the students name is, okay, Rahul. Now how you are going to identify the next one? By his surname, okay, by his surname. So suppose his surname is Sharma, another's is, okay, so by different surnames. So like that. So each electron in an atom, they are identified by four set of quantum numbers. Okay. So similarly, how we are going to represent a student, each student is different. Okay. So like that, the electron in an atom, they are identified by four different quantum numbers. So which is the first quantum number? It is a principal quantum number. Okay, it is a principal quantum number. It is represented by small n. Okay, it is represented by small n. And what it represents? It represents the main energy. Okay, it represents the main energy or the shell in which the electron is present. That is, it is represented as K. Okay, so K is the principal quantum number. So it represents the main shell, okay, where the electron is residing. In which, okay, in which area the principal quantum number is residing, that is represented by the principal quantum number. So where the electron is staying, okay, that is represented by what? It is represented by the principal quantum number. Okay, it is represented by the principal quantum number. Okay, so this is about your principal quantum number, where he is staying. Then second one is so which are the different? Suppose the principal quantum number, it is staying, the value is 1. Okay, if the principal quantum number, the value is 1, that means he is staying in K, okay, in K house, like that. If the value of the principal quantum number is 2, then he is staying where? He is staying in L house, like that. Then if the principal quantum number, the value is 3, then it is M. Okay. And if the value of principal quantum number is 4, then the value is N. So these are the only 4 possibilities. Okay. There is no 5, 6. So these are the only four possibilities. So if the principal quantum number is 1, then where the electron is residing, it is residing in K shell. Okay, K main shell. And if the principal quantum number is residing in 2, okay, then what it means? It means the house is L. If the principal quantum number is represented by 3, then it is corresponding main shell is M. And if the principal quantum number is 4, then it is N. Okay, like that. Now, next, so this was about the principal quantum number. Second is azimuthal quantum number. Okay, next is azimuthal quantum number. How it is represented? It is represented by L. How it is represented? It is represented by small l. Okay. What it tells you? Azimuthal quantum number. It tells you the shape. Okay. It tells you it tells you the shape of the orbital. Okay, it tells you the shape of the orbital. Azimuthal quantum number. Okay, it corresponds to the subshell. Subshell. Okay, subshell means what? So this is a main shell. Okay, main shell. So under this, what it comes? It is the subshell. So it represents the subshell, or it gives you the shape of the orbital. Okay. Now, how it is represented? L, the values of L will be from 0, 1, 2, 3 to n minus 1. Okay. N is what? N is your principal quantum number. Now how is your azimuthal quantum number represented? If the value of L is 0, it starts with what? The value of L starts with 0 and N starts with 1. Okay, 1, 2, 3, and 4. Here, if the azimuthal quantum number, if the value L is equals to 0, what it is represented? It is represented as S subshell. Okay, it is represented as S subshell. What is the shape? It is spherical in shape. We know that, right? S is spherical in shape. Then azimuthal quantum number 1. What is the shape? Okay, it is P. It is P. What is the shape of P orbital? Anybody? Anybody knows what is the P? What is the shape of P orbital? Anybody knows what is the shape of P orbital? It is, what is the shape of p orbital, students? It is dumbbell shape. Okay, it is dumbbell. Okay, it is a dumbbell shape. So whenever value of L is 1, it is represented as P. The shape is dumbbell shape. Okay. Then if the L is 2, then the subshell is D. Okay, D. What is the uh, uh, shape of D? It is double dumbbell. Okay, double dumbbell shape. So the name is given as double dumbbell shape. Okay. Then 3. Okay, when the value of L is 3, the the shape of the orbital is F. Okay, F. So these are this represents the azimuthal quantum number. This represents what? Azimuthal quantum number. Okay, very important. Quantum numbers are very important from your theory point as well as for CET point of view. Okay, many questions are asked from this particular chapter. Fine. So this was about two important things: principal quantum number and azimuthal quantum number. Okay. Next is what? Next is magnetic quantum number. The third one is magnetic quantum number. Magnetic quantum number, it tells you the magnetic behavior of an electron. It tells you the number of orbitals in a subshell. It tells you what? It tells you the number of orbitals in the subshell. Okay. Now, S orbital. How many electrons it can accommodate? How many orbitals are present in S? It is one orbital. Okay. So magnetic quantum number, it describes what? It describes the number of orbitals in a subshells. So N represents what? N represents the main shell. Okay, it represents the main shell, that is your K, L, M, N, N. Then L is your azimuthal quantum number. What it represents? It represents the subshell. Okay, which are the different subshell? S, P, D, and F. Then is your magnetic quantum number. Magnetic quantum number describes what? The number of orbitals. Okay, number of orbitals. So in this S, P, D, and F, S has one orbital. P has how many? P has three orbitals. Okay, three orbitals. Then D has how many? Anybody? D has how many? D has five orbitals. And F has how many? It has seven orbitals. Okay, remember this. Very important. I hope you are noting down these things. Okay, so magnetic quantum number, it represents what? It represents the number of orbitals in a subshell. Okay, so S orbital contains one orbital, P subshell contains P subshell contains three, D contains five, and F contains seven. Okay, so S, how many electrons it can accommodate? Maximum number of electrons which can be accommodated in the S orbitals is 2. Okay, 2 electrons it can accommodate. P, how many electrons it can accommodate? 1, 2, 3, 4, 5, and 6. So 6 electrons. Then D orbitals 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 10 electrons it can accommodate. Okay. And F orbitals, how many? 14. 14 electrons it can accommodate. Okay. So this is magnetic quantum number. It tells you how many number of orbitals are present. In S, you have one orbital. P, you have three orbitals. D, you have five. And F, you have seven. And what are these 2, 6, 10, and 14? They are the maximum number of electrons which can be accommodated in these orbitals. Okay, so these are the three quantum numbers which we have seen. The last one is the spin quantum number. Okay, spin quantum number, it is represented as ms. Okay, it is represented as ms. It represents the direction of electron spin. Okay, it represents the direction of electron spin. Okay, so it is represented by either two values, that is plus half and minus half. Plus half means what? Plus half means the electron is in clock upward. Okay, and minus half means it is downward. So these are the only two spins possible for an electron, plus half and minus half. Is it clear about quantum numbers? Is it clear about quantum numbers? So these are the four important quantum numbers. Okay, so these are the four important quantum numbers. So principal quantum number, azimuthal quantum number, then magnetic quantum number, and spin quantum number. Okay, so based on this, so why I took quantum number? Because it is very important for theory point of view as well as for CT point of view. Okay, so we are going to solve the question now. Okay, so here is our first question. You can see. Okay, fine. Let us start with the first question. When the azimuthal quantum number has the value of 2, the number of orbitals possible are A, 3, B, 0, C, 7, and D, 5. So just now I have told you what is azimuthal quantum number, and I have told you what does azimuthal quantum number tells you. Azimuthal quantum number tells you about the subshell. Okay. So what are the number of orbitals? So azimuthal quantum number, it is represented, it has a value of 2. Okay. So L is equals to 2. L azimuthal quantum number, it is represented by what? L. So value of L is what? The value of L is 2. So in L is equals to 2, what is the number of orbitals? Yes, options are given. Tell me. Try to answer. So we have seen L is equals to K, L, M and N. Okay. So then we have another thing, that is L. So when L is equals to, okay, Shravanya has answered it as A. Others? So the L value starts from 0. So when L is equals to 0, it is S. When L is equals to 1, it is P. When L is equals to 2, it is D. Okay, when L is equals to 3, it is S. So when L is equals to 2, it is which? It is D orbital. How many number of D orbitals are present? Now at least you can tell how many number of orbitals are possible in D.
5, ma'am.
Yes, Hema has answered it correct. Others have understood. So what are the number of orbitals? It is D. Okay, it is D. So L is equals to, so like this they have asked. So the value of L starts from 0, 1, 2, 3 up to L is to L minus 1. So when L is equals to 0, it is S. L is equals to 1 is P. L is equals to 2 is D. So in D orbitals, D subshell, the number of orbitals are 5. So it is D. Okay. Another you can, so D, D orbital. Okay. So which are the 5 D orbital? That is dxy, dxz, dyz, dx square minus y square and dz square. Okay. So these are the 5 orbitals which are present in the D subshell. Okay. D subshell. Is it clear? Okay. Let us go for the next one. So like this, the question is asked. Okay. The correct set of 4 quantum number for outermost electron of potassium, that is the atomic number is given as 19. So these are the 4 different sets of electron for a potassium. So potassium, let us write, potassium is represented by K. The atomic number is 19. Okay, atomic number is 19. Let us write. So the electrons filling will take place from 1s2, then 2s2, right? We know according to Aufbau principle how the electron filling takes place. So the electron filling takes place from lower orbital to higher orbital. So it is 1s2, 2s2, then 2p6, okay, 2p6, then it will go to 3s2, then 3p6, okay, count the number of electrons, 2, 4, 10, 11, 12, 13, 14, 15, 16, 17, 18. One more electron, it will go to 4s1. Okay. So what they've asked, you have to write the correct set for this particular 4s1 orbital. Okay. 4s1. Now, what does 4 represent? 4 represents your first string. Okay. Which are the 4 this quantum numbers? First one is your principal quantum number. Okay. Principal quantum number. Principal quantum number represented by n. Okay. And what it represents? It represents the main shell. Okay. It represents the main shell. So here, which is the main shell? The main shell is 4. Okay. 4. So the value starts from what? The starts from 1, 2, 3 and 4. 4 means what? N is equals to 4. So n is 4. Okay, so here the principal quantum number is n is equals to 4. So this is the main shell, that is principal quantum number. Second one is azimuthal quantum number. Second one is what? Azimuthal quantum number. Okay, azimuthal quantum number. It is represented by what, students? It is represented by L. Okay, it is represented by L. Now, it starts with L is equals to 0, 1, 2, 3, etc. Okay, now here, what is the, when 0, okay, when it is 0, it is s orbital. So, what is here? S is present. So, L, what is the value of S, L, L here? L is equals to 0. Okay, because we have S subshell. We have what? We have S subshell. So L is equals to 0. Okay, we got second one also. Now, third one is what? Magnetic quantum number. Next is what? Magnetic quantum number. Okay, magnetic quantum number represented by ML. What it tells you? How many orbitals are present? Okay, how many orbitals are present? Now, how many orbitals are present here? So in M, so when L is equals to 0, okay. So here the magnetic quantum number for 4s is 0. Okay, it will be 0. It will be 0. Then next is what? Spin quantum number. Okay, spin quantum number, 1 electron is present, so it is half. Okay, so the answer, just see what is the correct answer now. What
Option
is the
C, ma'am.
option C? Okay, Hema is answered. Kavya has answered here. Okay, so what is the correct answer? The correct answer is C. Okay, 4, N is 4. It represents the magnetic quantum number. That is your main, sorry, it represents the main shell. Then azimuthal quantum number. Okay, L is equals to 0. Magnetic quantum number is 0. And next is your spin quantum number. That is only 1 electron is there. So it is half. Okay, it is half. That is plus half or minus half, anything. But only 1 is there. So half. Okay, so the answer is C. Answer is what? C. Okay, fine. Let us go for the next one. A body of mass S. Okay, a body of mass x kg. Okay, so a body is moving with mass x kg with a velocity of 100 meter per second. Velocity is given. What is the velocity, students? Velocity is given as 100 meter per second. Okay, it's de Broglie wavelength. The de Broglie's wavelength is 6.62 into 10 raised to minus 35 meter. Okay, so mass, we have to find what is the mass. Mass is given as x kg. Okay, and what all is given? Planck's constant is given. Planck's constant is 6.62 into 10 raised to minus 34 joule second. So which is the de Broglie's equation? Which is the de Broglie's equation? So that is de Broglie's equation is lambda is equals to h by mv. Okay, this is your de Broglie's equation. Okay, I think I have. Okay. So what all we have seen here? So we have seen the okay. So there is a okay. So here previous question. Yeah. So here what all things are to be given? So the formula. So mass is given. Mass is x kg. Okay. Velocity is 100 meter per second. Okay. De Broglie's wavelength. Wavelength is 6.62 into 10 raised to minus 35 meter. And h is your Planck's constant, 6.62 into 10 raised to minus 34 joule second. So according to De Broglie's equation, the formula is lambda is equals to h by mv. Okay, according to De Broglie's equation, lambda is equals to h by mv. Okay, so put the values now. Put the values here. Yes, did you get the value? So lambda is equals to so 6
0.1 kg, ma'am.
0.1 kg. Okay. Others? Okay. Kadiravan has answered as 0.1 kg, 6.62. Okay, easy substitution, 6.62 into 10 raised to minus 35 is equals to 6.62 into 10 raised to minus 34. Okay, upon x into 100. Okay, we don't know the mass. So what I'm going to do, I'm going to transfer this here and this here. So 6.62 into 10 raised to minus 34 by 6.62 into 10 raised to minus 35 into 100. Okay, x is equals to. So after this simple calculation, you are going to get what? 0.1 kg. Okay, 0.1 kg. So the answer is D. Yes, Kavya has also answered as D. So remember the De Broglie's wavelength equation, that is lambda is equals to h by mv. Okay, lambda is equals to what? H by mv. Understood? Is it clear? Are these three questions clear? Okay, so this one is the easy question. Next one, the wave number. Okay, so this is with respect to Rydberg's equation. This will do later. Okay. So your okay, we will do for this one quantum numbers. Okay, fourth one we will do okay, because we have not done the synopsis for that. So fourth one we will do in next class. Fifth one, the set of quantum numbers for the outermost electron of copper in its ground state is. What is the copper atomic number, student? Anybody knows what is the copper atomic number?
29.
Yes, very good. Hema has answered is correct. It is 29. So let us write. So do you know how to feel the electrons? Okay, let me show you the table. Okay, how to feel the electrons. Let me show you the table here. Okay. So can you see this particular? So the feeling of electrons. Okay. Here you can see, yes, this is feeling of electrons. Okay. How the feeling of electron takes place, students? So let me zoom this. Okay. So the feeling of electrons takes place by this. Okay. Okay, here you can see. So first the electron will enter from lower orbital. So 1s is the lower orbital. So from 1s, then the electron will enter into 2s. Then it will go into 2p, then 3s, then 3p, 4s, then 3d, 4p, 5s, then 4d, 5p, 6s, then 4f, 5d, 6p, 7s, 5f, 60 and 7p. So this is the lower energy. So here the electron is filled in the lower energy and this is the higher energy. Okay. So the filling of electron takes place from lower orbital to higher, that is the higher energy orbital. So this is a filling up of electron. Okay. So this principle is called as Aufbau principle. Okay. You might have studied in this chapter, that is Aufbau's principle. Okay. What do you mean by Aufbau's principle? In Aufbau's principle, we are discussing the how the electrons filling will takes place. So let us put now the electrons filling of copper. Okay. So let us put the electron filling of copper now. So how we are going to fill the electrons here? Just see. So first, okay. I think now the screen is visible. Okay, fine. So let us start the filling up of electrons. So copper is 29. Okay, so let us start. How it will start? So 1s, 2, then 2s, 2, then 2p, 6. We know in S, the maximum number of electrons are 2, p, 6, d, 10, f, 14. Okay, so let us start filling. 1s2, 2s2, 2p6, then 3s2, then 3p6, 3d10. Okay, so just see 2, 4, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 10 is 28, and then is 4s1. Okay, now write down for 4s1. What they have asked, write the set of quantum number for the outermost electron. So which is the outermost electron? 4s1. So write down now, students. So which are the four quantum numbers? You have to tell the value for N, L, M, that is your magnetic quantum number, and magnetic spin quantum number. So what is the value here? Yes. So what is N? The value of N is 4. Okay. Because the main shell is 4 here. Then magnetic quantum number S represents 0. Okay. S is 0. That is, it tells you the shape of the orbital. So it is 0. Next is the magnetic quantum number. It is also 0. And the number of electrons are 1. So it is half. So it is a plus half. So which is the answer? Which is the answer?
Option C, ma'am.
Option C. Yes, correct. Okay, option C. That is 4, 0, 0, and plus half. Either it is plus half or minus half. Now you can see that in all the options, it is plus half only. So we'll consider plus half. Okay, either plus half or minus half when one electron is there. If both the electrons are there, then it will be plus half and minus half together. Okay, so this is the set of quantum number. Is it clear? Okay, this will take another question is there. This we will solve in the next class. Okay, this will take more time. Now here, if the energy of two photons are in the ratio of 3:2, okay, if the energy of the two photons are in the ratio of 3:2, then their wavelengths will be in the ratio of what? Okay, what will be the wavelength of their ratio? How is energy given as? Energy is equals to h by mu. Okay, energy is equals to h by lambda.
Hello.
Okay. So here energy is given by what? Energy is equals to hc by lambda, right? Hc by lambda. So energy is what? I said energy is directly proportional to lambda. According to what? According to Planck's constant theory. So if the energy of the two photons are in the ratio of what? 2 is to 3 is to 2. So if E1 and E2, okay, are in the ratio of 3 is to 2, what is the wavelength? Okay, what will be the wavelength? Wavelength is inversely proportional. So the wavelength ratio is what? It will be lambda 2 by lambda 1. That is 2 by 3. Okay, it will be what? 2 by 3. So which is our answer?
Option B, ma'am.
Yes, option B. Okay, understood. So according to Planck's theory, E is equals to hc by lambda. So how is energy associated with the wavelength? It is inversely proportional. So if the ratio of E1 by E2 is 3 is to 2, okay, so lambda is inversely proportional. So it will be lambda 2 by lambda 1. Okay, so lambda 1 value will be 3 and lambda 2 value will be 2. So the ratio will be 2 is to 3. So option number B. So this is how energy is associated with wavelength. Okay, is it clear? Okay. The remaining questions, okay, based on the different concepts, so that we are going to see in the next class. Any doubts up to here? Any doubts up to here?
No, ma'am.
Okay. Yes, fine. So in the next class, we are going to continue with the same topic. So thank you. Okay, so I am going to end this session here. So we'll meet in the next class. Thank you, dear students.